Foundation of Fourier series. In this video, we are going to learn what do you mean by Fourier series and when we can write the Fourier series. Second point, we will cover the basic concept used in a Fourier series, that is a periodic function, then some integration formulas, then the values of sine and cos at different values of theta in a journal form. Beginning with the Fourier series, basically a Fourier series is a way to write a periodic function in terms of sine and cosine. So if we have any periodic function, we can express that periodic function in the sum of sine and cosine function. And that sum is basically an infinite sum of sine and cosine. Now, when it is used, Fourier series is used whenever we have a waveform, such as we are receiving some signals where the signal processing is used. In that case, we can use the Fourier series in order to manipulate that signal wave. Starting with the periodic function. So, periodic function f means it has a certain period t. Suppose we are taking a function having a period t. It means after t period, it gets the same function. Means after period t, we are having a same function. So we are getting a repeated pattern in that case. And mathematically, we are writing the periodic function in this form. Let's understand with the help of these two figures. So over here we are getting a zigzag form and it is a similar form we are getting after some time. So if you observe from -4 to -2 we have a upper triangular and from -2 to 0 we have a lower triangular and same triangular we are getting from 0 to 2 and lower triangular from 2 to 4. So we are getting a repeated form after the length of interval 4, because till now we have a one graph and after that from 0 to 4 we have a same graph. It means it is a repeating after the interval of 4 because the length of this interval is 4. Even you can observe from -2 to 2, lower triangular, upper triangular. Same we have a lower triangular, upper triangular. Now this pattern is repeating after the interval of 4. So it means whatever this function is, its period is 4. So this function has a period 4. Same in this case. Now you can observe from -2 pi to pi, we have a upper circle, and from -pi to 0, we have a lower semicircle. From 0 to pi, we have a circle that is a upper semicircle. And from 0 to 2 pi, we have a lower semicircle. And same after that one. So it is repeating after what interval? So if you observe, the length of this interval is from 0 to 2 pi. So the interval length is 2 pi. After 2 pi, it gets start repeating. Same over here, it is repeating over here. So in this case, whatever the function is, its period is 2 pi. This is how we can predict from the graph. Now, whenever we have a periodic function, it means we can write its Fourier series, that is, a expression expressed in form of sum of sine and cosine. Now, we have taken certain periodic functions. We need to learn what is the period of that trigonometric function. So, we are well aware that the sine, cos, secant, cosecant, it is repeating after the interval of 2 pi. Therefore, its period is 2 pi. Whereas for the tan and cot, its period is pi. We have another result. If suppose any function is given to you, its period is p. Now we have changed this angle. Rather than x, the angle is ax plus b. In that case, it is again a periodic function, but the period is changed. What is that period? That period of fx divided by coefficient of x, but it is in a positive form, that is a modulus of coefficient of x. For example, cos x is a periodic function with period 2 pi. Now, in case you want the period of cos 2x, that is equal to, take the period of cos x, that is 2 pi, divided by coefficient of x but in a positive quantity, that is mod of 2. So this is equal to pi. So cos 2x period is pi. So if this angle is double, then the period is divided by 2. These are some important formulas of integration. So first is integration of e raised to power ax, that is e raised to power ax by a plus some constant, because we are dealing with the indefinite integration. Integration of x raised to power n is x raised to power n plus 1 divided by n plus 1 plus some constant. Integration of sin ax is minus cos of ax divided by a plus some constant. Integration of cos ax is sin ax by a plus some constant. Now there are another two important forms, that is the integration of e raised to power ax into some cos or maybe sin. In this case, you can observe that starting term is same, that is e raised to power ax function as it is, divided by a square plus b square, where a and b are the coefficients of x in exponential and sine or a cos term, into a cos bx. This term is as it is but multiplied by the coefficient of x in exponential, and same sin bx as it is but multiplied by the coefficient of x in an exponential, plus b times of sin bx, and here minus b times of cos bx. Next we need the integration by parts. Whenever we have a two different functions of x, in that case we can apply the integration of by parts, that is applied with the help of eyelid, where I stands for the inverse function, L stands for the logarithmic function, A stands for the algebraic function that deals with the polynomials, T stands for the trigonometric function, and E stands for the exponential function. According to the eyelid, we can identify which one is the first function and which one is the second function. For example, if we have e raised to power x into x square dx. So x square is an algebraic function and exponential, that is e. So in eyelid, a comes earlier than e. So it means this is the first function and this is the second function. This is how we are finding the first function and second function. After identifying the first function and second function, we have the form u as a first function as it is, integration of a second function, minus, take the derivative of first function, integration of second function, then whole integration with respect to x. This formula can also be written as integration of u and v. Suppose u as a first function and v as a second function. So we will keep this u function as it is over here. Then integration of v, keep that answer over here. Suppose it is a v1. So suppose we have sin x. So sin x integration is minus cos x. So we will write minus cos of x as it is over here. Minus, take the derivative of this term and further take the integration of v1. Means if we have minus cos x, take its integration along with the negative sign, plus derivative of this term, then take its integration, minus derivative of this term, then take the integration of v3, that is v4. Observe the signs. So first one is a positive, then negative, then positive, negative, positive. With the help of this form, there is no need to apply the integration by parts more than once. We can directly find the value within a one step. Another important formula we need as integration of cos nx dx is always 0 from the interval a to a plus 2 pi. So whenever the difference between the interval is 2 pi, in that case, if you take the integration of cos x, cos 2x, cos 3x, any angle of cos, in that case the answer is 0. Make sure that n is integer. So if you want to evaluate, what we can write, cos n pi integration is sin nx upon n. Lower limit is a, upper limit is a plus 2 pi. So we can take 1 by n outside, substitute the upper limit. When you substitute upper limit, what we have, sin n into a plus 2 pi minus sine of n into a. This is equal to 1 upon n sine. Simplified form of this one is, it is 2n pi plus na minus sine na. This is equal to 1 by n sine 2n pi plus na is sine na minus sine na. So this term will get cancelled and hence we have 0. So as we have already calculated, integration of this one is 0. Similar way we can find the integration of sin x from a to a plus 2 pi. The length of the interval is 2 pi. In that case the integration is also 0. Next is integration of cos mx into sin x from a to a plus 2 pi, where the length of the interval is again 2 pi. In this case, if you replace m and n with any of the integer, maybe they are equal, still the integration is a 0. And when we are taking the function as a cos into cos with the different angles, integration from a to a plus 2 pi, in this case, again the integration is 0, and same in a sine case. Make sure the integration is taken from a to a plus 2 pi, means the length of the interval is 2 pi. Now you can observe from the graph, here we have taken the curve as a sin x into sin 2x from the interval 0 to 2 pi. If you observe, area under this curve is 0. Now observe the pattern for sin 3x into sin x. Again in this case, area under this curve is 0, and same observation you will have till they are not seen. Now when you take sine into sine, in that case it is a sine square x. So in that case area is pi rather than 0. And if you observe the curve sine square 10x, in this case again area under this curve is pi. But interval in this case is same, 0 to 2 pi. So we can say that sine square mx from a to a plus 2 pi, this is equal to pi. And similarly for cos square mx, its integration is pi from a to a plus 2 pi. Next we will learn the values of sin x and cos x. So here we have considered the graph of sin x, and if you observe that sin 0 is 0, sin pi is 0, sin 2 pi is 0, sin 3 pi is 0, same for 4 pi, even sin at minus pi and minus 2 pi is 0. So we can say that in general sin n pi is 0. And if you want to take n minus 1 into pi, means a multiple of pi as n minus 1, still it is a 0. And if you take n plus 1 into pi, again it is a 0. But if you observe for the pi by 2, in the case of sin pi by 2, its value is 1. In case of sin 3 pi by 2, it's a minus 1. Sin 5 pi by 2 is 1. If you observe, we have odd multiple of pi by 2. 1 pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. And in this case, the values are 1, minus 1, 1, minus 1. So we are getting the alternative values. So we can say that the answer in this case is minus 1 raised to power n. Next we will find the values of cos. So if you observe that cos 0 is 1, cos pi is minus 1, cos 2 pi is 1, cos 3 pi is minus 1. In general, we can write this as is equal to minus 1 raised to power n. So if you observe that 2 is there, so we can take the power 2 minus 1 square is 1. If it is a 3, minus 1 raised to power 3 is minus 1. Now, the point is what is the value of cos n plus 1 into pi? So, in this case, cos n pi is minus 1 raised to power n. So, in place of n, we are substituting n over here. In this case, the answer is minus 1 raised to power n plus 1. And over here, minus 1 raised to power n minus 1. Now cos 2n plus 1 into pi by 2. So it is a multiple of pi by 2, but that is the odd multiple. So in this case, cos pi by 2 is 0, cos 3 pi by 2 is 0, cos 5 pi by 2 is 0. It means this answer is 0.